What's going on, guys? In this video we are going to see an example on Newton's law of cooling. Here let's look at this problem right here. This question is asking, mine tailings which has been heated to 110 degrees Celsius in the oven is cooled at room temperature 25 degrees Celsius. An hour after, it is found that the thermometer reading is 90 degrees Celsius. Determine the temperature of the tailings after 3 hours. So they are asking to find out the temperature after 3 hours. Okay, this is our question, and we have to know that for a Newton's law of cooling, the generic equation is going to be this: dt by dt is equal to k times T minus C. So this dt by dt is temperature change with respect to time, and here this k is a constant, this T is temperature of the body, this C is temperature of the surrounding. Now we have this temperature of the surrounding, right? Now let's plug this one and see whether we can create an equation using that. So dt over dt is equal to k times T minus 25, and from this one you can see this is a separable equation, so we can separate and integrate and derive a new equation. From this one we can, let's bring the like terms together. So dt by T minus 25, and in the other side we are going to have k dt. Now we separated this one, now let's integrate. So if I integrate this one, this is going to become ln of T minus 25. Okay, so we don't have to worry about the absolute value. And in the other side we are going to have kt. K is a constant. If we integrate dt, that's going to be just t, and we have to have a constant, let's say that is c. Now to get rid of this ln, we can take e power both sides. So the e power this, e power this, e power ln cancels each other. We will end up with T minus 25, and in the other side we are going to have e power kt times e power constant, and e power constant, let's equate that one to c1. Okay, so we can write this one as T minus 25 c1 e power kt. So from this one we can derive an equation that is T is equal to c this 25 plus c1 e power kt. Okay, now we have this first equation. Now let's see whether we can find any other information using the given informations. And here we have an initial condition given. So this is when temperature at time 0, that is equal to 25 plus c1, and when temperature at time 0, this time is going to be 0, and we know that the temperature time 0, that is 110 degrees Celsius. So we can plug that one right here. 110 is equal to 25 plus c1 e power 0, and 110 minus 25, that's going to be 85, is equal to c1 e power 0 is going to be just 1, so c1 is equal to 85. Okay, now from this one we can create, like we can bring more to this equation. That's going to be T is equal to 25. Now we can add this 85 to this equation. That's going to be 85 e power kt. Now we have another information provided. An hour after, it is found that thermometer reading is 90 degrees Celsius. So we have the time and the temperature at that time. So we can use that to find this constant. Okay, temperature at 1 hour, after 1 hour, this is going to be 25 plus 85 e power k times 1. Okay, now from this one let's see what we can, and this is provided, that is 90 is equal to 25 plus 85 e power k. Now if I bring this 25 to this side, 90 minus 25, that's going to give us 65. That is equal to 85 e power k. Therefore 65 divided by 85, so e power k is equal to 65 divided by 85. Let's get rid of this part. Now to get rid of this e, we can take ln both sides. So this is going to be ln of e power k is equal to ln of 65 divided by 85, and this k moves to the front, and ln and e gives us 1. So this is going to be k is equal to, if you calculate this value, you should get, let's keep it as ln and simplify this one. ln 65 divided by 85, that's equal to 13 divided by 17. Okay, I divide both by 5. Now this is our k value. Now we can create a new equation. Okay, let's get rid of this part. Our new equation is going to be T temperature at time is equal to 25 plus C1 is 85, e power k value is ln of 13 over 17, ln of 13 over 17 times T. Okay, now the main question here is to find the temperature after 3 hours. Okay, now this is the purpose we derived this equation. Now let's go ahead and plug this one in this equation and find the temperature after 3 hours. So T at 3 is going to be equal to 25 plus 85 e power ln of 13 over 17 times the time, that is 3, and if you calculate this one you will end up with 63.01 degree Celsius, and that's going to be the temperature after 3 hours, and that's going to be the final answer. I hope this helps. Thanks for watching.